In today's lesson, we are going to be looking at problem solving using the vertex form. So this is going to be taking what we've learned in the previous couple lessons and in some of the previous units and basically just kind of solve some application questions. So just as a warm-up, a little bit of review from the last lesson. We want to go through and write the following equation in vertex form and then sketch a graph by hand. Right, so we have our standard form, and while we're in standard form, we might as well look for some key information. In this case, we do have our y-intercept, so it doesn't hurt to know that, especially when we have to go and graph it. Now, because we are trying to turn this equation that is in standard form into vertex form, we need to complete the square. So in this case, as following the steps from our previous lesson, I'm going to put the first two terms in brackets. Now, because the first, the variable or the coefficient, in front of the x squared is 1, I don't need to factor anything out. Or because my a value is 1, I don't need to factor anything out. Now what I'm going to do is I'm going to look for my magic number. So I put brackets around the first two terms. I'm going to find my magic number by taking the second value, or the b value, dividing it by 2 and squaring it. So 4 divided by 2 is 2. Squared is back to 4. So I have x squared minus 4x plus 4 and minus 4. And then I have minus 5 still outside the bracket. So that magic number, I add and subtract it to my bracket. I have to move the negative value outside of the bracket. X squared minus 4x plus 4 minus 5 minus 4. Inside this bracket, it should be a perfect square trinomial, or a perfect square, which is why we input the magic number in the first place. So in this case, it is going to be x for the first term, 4 for the second, or sorry, not 4, 2 for the second term, the square root of the first number, square root of the last number, and then the sign now is going to be negative because that is the sign between the first two terms. That is going to be squared. And then on the outside, I have minus 5 and minus 4, or combine those like terms, I get minus 9. So therefore, my equation in vertex form is y equals x minus 2 squared minus 9. Now, if I want to go through and, and graph this, I'm going to draw my axes. I know I have a y-intercept at minus 5. So somewhere down here, we'll say we have a y-intercept. We have a vertex at minus 2, or at 2 and negative 9. Over at 2, down at negative 9, again, roughly about here. And the step pattern, so let's write down what we have. So we have our vertex, which is 2, negative 9. Our y-intercept, which is negative 5. We do know our step pattern, which is 1, 3, 5, because our a value is 1. So if I wanted to, I could go over and say, okay, go over 1, up 1, over 1, up 3. Right, I'm just roughly sketching it. But if we had an actual grid, we could go through and graph it. But at least we kind of see something that is roughly similar to what we've done, or to a rough sketch anyways of our graph. And that is all from our standard form, right? We converted it to vertex form, which makes it easier to graph. It gives us more key pieces of information. So this might be something we have to do when we go through some of these application questions. So in the first question, Chester is going parachuting. A quadratic relation is used to determine his height h in meters and his time t in seconds after exiting the plane. In this relation, a is equal to negative 0.5 g, where g is the acceleration due to gravity, 9.8 meters per second squared on Earth. And if Chester exits the plane at a height of 554 meters, how long will he be in free fall before the parachute opens at 300 meters? So we need to come up with an equation that will represent his quadratic path. And what we know with Chester and what we know with his path, right? He's in an airplane. So if we kind of draw an airplane to kind of represent this, let's see how well our drawing can be. So he's in an airplane. Maybe it's like we'll add a little engine to it. So he's in an airplane and he's going to jump out. So if he jumps out of the airplane, he's going to basically fall down, right? So we kind of have half of our parabola here. We do know what the height is, right? The height of this is going to be if we're dealing with time. So when time is 0, the height is 554, right? So our vertex we're given based on the scenario of our question. So we're told the vertex, right? And we're looking for how long will it take until he reaches 300 meters. So we're looking for an x value. So we have to come up with an equation first though. Because we're given the vertex, we can use our vertex form. So I'm going to start with y equals a, x minus h squared plus k. Our vertex, which is the 0 and 554, I can plug that into my equation. So y is equal to a times x minus 0 squared plus 554. Simplify this, y is equal to a x squared plus 554. Now we are told our a value as well. Back up in our question, we're told that a is equal to negative 0.5 times g. And we are told that g is equal to negative 9.8. So that means our a value is going to be negative 0.5 times 9.8, or negative 9.8. And we get, sorry, not negative 9.8, positive 9.8. So that means we have an a value of negative 4.9. So that means our general equation, let's kind of shorten this up a bit, move some of this around just for space. That means in our general equation, we're going to have y is equal to negative 4.9 x squared, or sorry, keep it kind of consistent, x and the square on the outside plus 554. Now what we're going to do, or now what we're going to have to do, we are looking for when does the height equal 300. Right, so we're trying to figure out when height is equal to 300. So we know that h is going to equal 300. So what we're going to do with that is we are going to sub in 300 for h. Because we're told that's when the height is, or that's what we're looking for, we're going to plug that in, the height in for h, or in this case, for y. Right, because the y is going to represent our height. So in our equation now, we're going to have 300 is equal to negative 4.9 x squared plus 554. Now with this equation, I can solve for my x value. Very similar to if I was dealing with a linear equation and I was plugging in one of the coordinates and I had to find the other. So if I move the 554 on the other side, I'm going to subtract it from both sides. One side is going to cancel out. I'll be left with negative 254 equals negative 4.9 times x squared. Again, I'm trying to solve for x, so I'm going to get rid of this negative 4.9 first. I'm going to divide both sides by negative 4.9 because it's going to be multiply on one side. On the opposite, it's going to be, or the opposite is going to be division. You can get 51.8 is equal to x squared. Now the last thing I need to do is I need to get rid of this squared. I don't want x squared, I want x. What's the opposite of squaring something? Square root. So I'm going to take the square root of both sides. It's going to cancel out on one side, and I'm going to be left with 7.2 on the other side. So that means, therefore, it takes 7.2 seconds to reach 300 meters. So a little bit of a combination, right? We're coming up with our vertex form equation, and then we're plugging in a value for y and solving for x. So this is a little bit different. We haven't really done this where we've had to solve the quadratic equation for a specific value. Right? So this is a little bit of a new step, but we're still taking into account those kind of solving equation concepts that we've used in previous lessons and units. In the next example, a Taylor Swift cover band made up of cats called 1,989 Lives sold 100 tickets to their concert at $20 a ticket. They're planning to increase the price next year. The research shows that for each $2 increase in the price of a ticket, 5 fewer tickets are sold. So whenever they increase the price, less people are going to buy it. So the first thing we want to do is we want to determine the revenue relation that describes the sales. So we kind of have like the general idea of how they're going to be coming up with a revenue, right? Revenue is equal to the number of tickets sold times the price. Revenue is just how much money they're going to be making. So if I want to look at revenue, right, or I need to come up with some variables, so let's say let y equal our revenue. We need to let x equal something. And what we're going to do in this type of situation, when we're talking about increases in price, we're going to let x equal the number of increases. We're going to let x equal the number of increases. We can't let x equal the number of tickets sold, right? Because we already know how many tickets are being sold. We know the price. We know the price of the increase. We know the amount of tickets that are going to be, or the amount of tickets that it's going to change by. The only thing we don't know is how many times we're going to increase the price. Right? So we're going to use this to help us come up with our relation. I'm going to say have y equals, or the revenue equal, the number of tickets, which is going to be 100, but I'm going to lose or subtract 5 tickets for every increase in price, or it's going to be 100 minus 5x. For the sale price, or for the price, it's going to be $20 plus $2 for every increase. And now this is going to be my relation. And if you look at it, it kind of looks a bit like factored form. Right? So this is kind of like a factored form. Because it looks like factored form, or because it is factored form, right, we're basically we created a quadratic relation. So there's a quadratic relation between the revenue and the number or the number of price increases. And that kind of makes sense, right? If we think about the price of an object or of tickets, depending on what the price is, right? If the price is low, right, more people might buy it, but we're not going to make a lot of money. And if the price is too high, we might make more money, but not a lot of people are going to buy the tickets, which is okay because of the price that we're charging, right? So we can kind of hopefully see how it might form a quadratic. So what should be the selling price per ticket, or what should the selling price per ticket be to maximize revenue? So because we're dealing with the maximum revenue, or because we're trying to find an optimal value, this should tell us that we're looking for the vertex. So I want to find the vertex value, or I want to find the x value of the vertex, because that will tell me the number, the number of price increases. So if I'm going to find the vertex, I have two factors, and I can use those two factors to find my x-intercepts. So I'm going to take each of those factors and set them equal to 0. Because if I find my x-intercepts, I can use that to help me find my vertex. So I have 100 minus 5x equals 0. I'm going to bring the 100 over. It's going to be negative 5x equals negative 100. Divide both sides by negative 5. I get x is equal to 20. On the other side, 20 plus 2x equals 0. Move the 20 over. I get 2x equals negative 20. Divide both sides by 2, and I get x is equal to negative 10. So right now I know that my two x-intercepts for this quadratic relation are going to be 20 and negative 10. I can use that to find my axis of symmetry by doing 20 plus negative 10, add my values together, divide by 2. I get 10 divided by 2, or 5. So that means that my axis of symmetry, or the x value of my vertex, is going to be 5. So because I'm looking for the selling price per ticket to be at the maximum revenue, that is telling me that the x value is 5. So therefore what that means, therefore the max revenue will occur after 5 price increases. So the max revenue will occur after 5 price increases, and I have an equation for the price. If we go back up here, this is our price, and this was our number of tickets. So for the price, it's equal to 20 plus 2 times x. 20 plus $2 times the number of increases, or 20 plus 2 times 5, or 30. So therefore, $30 tickets will maximize the revenue. So in this case, we only needed to find the x value of our vertex to find out the price of the tickets that will maximize our revenue. C is now asking how many tickets will be sold at the maximum revenue. So in this case, if I'm looking for the number of tickets sold, I have an equation for the number of tickets, and that was 100 minus 5 times x. Right, so that was the other part of our revenue equation. The number of tickets is going to go down $5 for every price increase. And in this case, there are 5 increases. So I'm going to say 100 minus 5 times 5, or 100 minus 25, or sorry, 25, gives us 75. So therefore, 75 tickets will be sold at max revenue. Now the last part is looking for what is the maximum revenue. So in this case, I have my revenue equation. Right? We said it was y is equal to 100 minus 5x times 20 plus 2x. And essentially now we're just going to go through and find the y value of our vertex using the x value, which we already found. This is the y value of the vertex. I go back up just to kind of put it down. Maximum revenue was the vertex, but the selling price per ticket, we kind of had to work through that. So, yep. So the y value of our vertex, if I know that the vertex, let me bring this down a bit. If I know the vertex is going to be 5 and something, that means I have to plug in 5 into my equation. So 100 minus 5 times 5 times 20 plus 2 times 5. Y is equal to 75 times 30, or y is equal to 2,250. So therefore, the max revenue is $2,250 when we're selling the tickets for $30 a piece to 75 people. The last question, a little bit more typical, or not a little bit more typical, but again, something else that we might see. So the mighty Thor hits Loki with his magic hammer. Loki has a flight path as described by the equation y is equal to negative 2x squared plus 8x plus 10, where x is the horizontal distance in meters and y is the height in meters. What is the maximum height that Loki reaches when he reaches from this hit? We want to write the equation in vertex form. Now there's two different ways that you could do this, right? And now because we're trying to solve these equations, there's different ways that we can go about it. Right? So we could look to factor and find our equation in vertex that way, or we could look to complete the square. So two different methods, whichever way you feel more comfortable with or whichever way you can reason through is fine. Just keep in mind, because we're looking for the equation in vertex form and because we're looking for the maximum height, again, those things should be key to tell us that we are looking for the vertex. So I'm going to go through both, and then again, at the end, you can kind of prefer which ones you'd rather do. So if we were trying to factor, I have y equals negative 2x squared plus 8x plus 10. It doesn't look like a simple trinomial, but I'm going to try. So I'm going to see if I can common factor. In this case, I can take a negative 2 out. Leaves me with x squared minus 4x minus 5. So here I can continue to factor product and sum, because now in the brackets it's a simple trinomial. So two numbers that multiply to negative 5 and two numbers that add to negative 4. In this case I have negative 5 and positive 1. So in my brackets, negative 2 still remains, and I have x minus 5, x plus 1. From there, I can find my zeros, or my x-intercepts. And my x-intercepts are just going to be the opposite of these two values, because it is the simple, because it is a simple trinomial. So my two x-intercepts are going to be positive 5 and negative 1. Now that I have my x-intercepts, I can find my axis of symmetry by adding those two together. So 5 plus negative 1 divided by 2, or 4 divided by 2, or 2. Using that, I can sub x equals 2 into the equation. So y is equal to -2 times, again, it doesn't really matter what we're trying to use. So -2 times 2 squared plus 8 times 2 plus 10. And I should get 18. So now from this, I can write out my equation in vertex form. Y is equal to my a value, which in this case was, if I go back up, I already had an a value of -2. So y equals -2 x minus 2 from the axis of symmetry squared plus 18. The k value or the y value from our vertex that we found. So that's the equation of this parabola in vertex form. So in this case, we could say the maximum height, therefore the max height is 18 meters. Now the other method would be completing the square, right? Because we learned that we can complete the square to go through and turn our standard form into vertex form. So the first step said to put our equation in brackets, or the brackets around the first two terms. Next step, because the value in front of the x squared is not 1, we are going to factor out the coefficient. So I'm going to bring out a -2. That makes it x squared minus 4x plus 10 is on the outside. I need to find my magic number by taking the b value, or 4 or -4. It doesn't really matter because we're squaring it anyways. So we can take -4 if we want, divided by 2 squared equals -2 squared. If you're going to include the negative, then just make sure you put brackets around it when you square it. So we get 4. So that tells me I have to add and subtract 4 inside those brackets. X squared minus 4x plus 4 minus 4 plus 10. This minus value I have to move to the outside of the bracket, but I have to reapply that factor at the front, so I need to multiply by -2. I end up with y is equal to -2x squared minus 4x plus 4 plus 10 plus 8, because -4 times -2 is +8. I get y equals, then, when I go through, again simplifying, so I get y is equal to -2x minus 2 squared, because this bracket is now a perfect square trinomial. So the square root of x squared is square root of 4. The sign between the first two terms becomes our bracket. And we have plus 18. So we can see whichever method we go to, we still end up with the same vertex form equation. So again, the method of that you wish to choose is up to you. Right? You can see that it gets you the same answer. There's a few more steps, I guess you could say, in the factored form, although the calculations might be a little bit easier. So again, in this type of scenario, if it works, we can go through and we can find whatever value, or you can use whatever method you'd like. Right? Sometimes maybe we can't factor it, and so we might have to complete the square. Right? So again, it depends on the equation that you're given. The main idea here is just that we're using our quadratic formulas to find or answer more application type questions. Right? So these ones can be a little bit more challenging because it's not just going to be a cut dry write it in vertex form. like some of the other ones, right? So you have to really think about what is asking you. In some cases, it might be difficult to come up even with the equation itself, right? So make sure you are practicing these concepts so you do get stronger at them.